Today we're going to learn about a different type of equation. The equation that we've been working on so far for both arithmetic, which is an adding, subtracting pattern, and geometric, which is a multiplication or dividing pattern, are the type of pattern where I can give you the term number, such as 5. You can plug the term number, such as 5, into the equation, and your answer will be what the fifth term is using that explicit equation. So an explicit equation explicitly tells you the sequence, the number of the sequence in the sequence order. So I can ask you what the 100th is, plug in 100 for x, and then go ahead and solve for y. Now, recursive is very different than this. Recursive tells you exactly two things. The first thing that it tells you is what is the first number in the sequence. The second thing it tells you is basically your pattern. What do you do next? Now, the thing about recursive is it's very much the same, whether it's arithmetic or geometric. So you're going to memorize a very specific thing that you're going to write down every single time, and then two items that you're going to add to it. So it's asking the question, it's answering the question, what's next? So if I give you one term, the recursive equation will simply tell you how to find the next term. So I can't give you and ask you what the 100th term is unless you've already told me what the 99th term is. So if I told you what the fifth term is, you can tell me what the sixth. But you have to know the previous term in order to use that pattern to find the next term. So here's what it looks like. There are these two parts. You will write these down exactly the same every time, whether they're arithmetic or geometric. So you're going to write a sub 1 is equal to, and then the line below that, you're going to write a sub n plus 1 equals a sub n blank blank. Now, a sub 1 is simply means the first term. So you're going to write the first term in that first line. The a sub n plus 1 means next. It's the now plus 1, which means next, is your current term, which is a sub n. And there you're going to write the operation. If it's arithmetic, you're going to write whether it's adding or subtracting. If it is geometric, you're always going to write a times, a dot, the multiplication. And remember, if it's getting bigger, then it's going to be times a number that's greater than 1. If it's getting smaller, which we normally consider division, but we write all of them as multiplication, it's going to be a number between 0 and 0.99. So here is where we put our operation, and our last spot is where we put our pattern. Is it times 3? Is it plus 5? Is it minus 4? So that's going to be the pieces of information that you fill in. The part that you see in red here, you're just going to write down every time as a part of your answer. So here is our first example. We have the sequence -4, -1, 2, and 5. And as you can see, to get from one to the next, our pattern, we are adding 3. And you can see that our first term is -4. So we write down what we see here on the left in red. A sub 1 is equal to, and we write a sub n plus 1 is equal to a sub n. On top of our first one, it's asking us what the first term is. So we're simply going to look at the first term, and we're going to write that a sub 1 is equal to -4. Now, on our bottom one, we always write a sub n plus 1 is equal to a sub n, and we're going to write, in this case, our operation, we are adding plus 3, because our pattern to get from one number to the next is adding 3. And so this is our completed recursive equation. A sub 1 equals -4, and a sub n plus 1 is equal to a sub n plus 3. So when you're looking at this, you can recreate the sequence starting with the first number and then just add 3 as you're going. However, if I wanted to find the 100th term, we would have to go ahead and rewrite this in an explicit equation, which in this case would be y is equal to 3x, working backwards to find the 0, minus 7. And then I could plug in 100 and find the 100th term. But all this specific recursive equation tells you is the first term in your pattern. So let's go ahead and look at a geometric. 2, 10, 50. So as you can see, we're going to write those same things down that we did last time. So we have a sub 1 is equal to, and a sub n plus 1 is equal to a sub n. You're going to write this down every time. This does not change. We're going to go ahead and look at our sequence, and we're going to see what that first term is. As you can see, it's 2. So we're going to put that next to our a sub 1. So a sub 1 is equal to 2. Now we're asking for the bottom one, what's next? And we know that to get from 2 to 10 and 10 to 50, we are timesing it by 5. So we see that pattern is times 5, and we go ahead and write that as our next two things on our second equation. So our recursive equation in this case is a sub 1 equals 2, and a sub n plus 1 equals a sub n times 5. Now, once again, if I were doing an explicit equation for this, I would go ahead and work backwards, divide by 5 to find my 0, which is 2/5. And my equation would be y is equal to 2/5 times 5 to the x power. So that, of course, is my equation for a geometric explicit equation. So once again, explicit is where I can plug any number of the sequence in and find what that sequence term number is. In this case, it gives you two pieces of information only. It tells me the first term and it tells me the pattern. Let's go ahead and get some practice, ladies and gentlemen.